Hello, dear students of plus 2 medical, non-medical, respected teachers, friends. So I am going to discuss laws of radioactive disintegration. So what are the various laws of radioactive disintegration? The first law states that radioactivity is a spontaneous process. It doesn't depend upon external factors like temperature, pressure. It is a spontaneous process. Second, during disintegration, when elements decay, either an alpha particle or a beta particle is emitted. Either an alpha particle or a beta particle is emitted. Means alpha and beta particles are never emitted simultaneously, nor more than one alpha particle or more than one beta particle can be emitted. This is second law of radioactive disintegration. Third is radioactive alpha decay. Now, during disintegration, during alpha decay, what happens? Suppose XZA is the parent's nucleus, parent atom you can say. It changes to daughter nucleus, daughter atom, and emitted particle, alpha particle, and huge amount of energy is released. During this alpha decay, atomic number is reduced by 2 and mass number is reduced by 4. That's why He24 alpha particle is emitted and some energy is also released. This energy released is shared by both daughter nucleus and the emitted particle. For example, when uranium 92-238 during alpha decay takes place, it becomes thorium 90-234 plus He24, which is nothing but an alpha particle. During beta decay, suppose XZA is the parent nucleus, Y Z plus 1A daughter nucleus plus electron plus energy. So in this case, atomic number during beta decay, atomic number increases by 1, whereas mass number remains the same and an electron is emitted with some energy is released, which is shared by both electron and as well as the daughter nucleus. So for example, thorium 92-234 gives Pa 91-234 plus electron, which is nothing but beta particle. Then fifth law, when heavy nuclear elements decay, the number of atoms disintegrated per second, or you can say the rate of disintegration at any instant is directly proportional to number of atoms present in the sample at that instant. So means number of atoms disintegrated per second at an instant, or number of the rate of disintegration is directly proportional to number of atoms present in the sample at that instant. So this is called radioactive decay law especially. So which is very, very important. So state radioactive decay law, it states that number of atoms disintegrated per second or the rate of disintegration is directly proportional to number of atoms present in the sample at that instant. Therefore, let n naught is equal to number of atoms present in the sample at t is equal to 0 initially. N is equal to number of atoms present in the sample at time t is equal to t. Then let dn is equal to small number of atoms disintegrated during small time interval dt. Then rate of disintegration will be equal to minus dn by dt. Negative sign means it is rate of disintegration. Number of atoms are being reduced in the parent nucleus. So minus dn by dt. So by radioactive decay law, so minus dn by dt is directly proportional to n, number of atoms present at the given instant, or minus dn by dt is equal to minus dn by dt is equal to lambda n. Lambda n is a constant of proportionality, and lambda is called disintegration constant, or dn is equal to minus lambda n dt, or dn upon n is equal to minus lambda dt, or we integrate it from n naught to n, 0 to t, because corresponding time t is equal to 0, number of atoms n naught, and corresponding t is equal to t, n is equal to n. So integral of dn upon n is nothing but log n. So limits n naught to n is equal to minus lambda, integral dt is t, 0 to t, limits put n is equal to upper limit log n minus log n naught is equal to minus lambda t, or log m minus log n is equal to log m upon n. So therefore log n upon n naught is equal to minus lambda t, or by definition of log, if e is base of log, so n upon n naught is equal to e raised to power minus lambda t, or n is equal to n naught e raised to power minus lambda t, which is the required expression for radioactive decay law. And from this equation we can see that if we plot graph taking time along x-axis, the number of atoms remained or present in the sample along y-axis, so we get the graph like this. So at t is equal to 0, number of atoms n is equal to n naught, then it decays exponential. It means the rate of decay is exponential in nature. N is equal to 0 will be an whole sample gets decayed, so t is equal to infinite. So to define lambda, put t is equal to 1 by lambda in this equation. So we have n is equal to n naught e raised to minus lambda into 1 by lambda. Lambda cancels, e raised to minus 1, so or n is equal to n naught by e. So it means what is decay constant or disintegration constant lambda? It is defined as reciprocal of the time during which number of atoms decays to 1 by e times its initial value. That is called decay constant. So reciprocal of time. So lambda has dimensions of t minus 1, second inverse. So this is all about laws of radioactive disintegration. So watch this video and everything will be clear to you. Good luck, be happy, stay tuned to get next video very soon. All the best, good luck. Thank you.